Namaste everyone, welcome to the class. Now, in this lecture, we will see midpoint theorem and converse of midpoint theorem. So, let us first begin with midpoint theorem. Midpoint theorem. Now, what midpoint theorem says that in a triangle, let's draw, this is okay, fine, perfect. In a triangle ABC, if I join the midpoint of two sides, say if I join the midpoint of side AB and side AC, then the segment which I will get will be parallel to third side. So that is EF will be parallel to third side and EF will be half of the third side. This is your midpoint theorem. What is midpoint theorem? That in a triangle, if we join the midpoints of two sides of the triangle, then the segment formed is parallel to third side and half of it. So midpoint theorem is that this EF is parallel to BC and second, this EF is half of BC. Let us prove it. For proving this, what I will do, I will draw a line parallel to this BA from point C. So we will draw one segment, say this is CG. Okay, this is CG, and then I will extend this EF, which cut this CG at some point, say H. Okay, this is our construction. You can write construction. What we have done, draw CG parallel to BA. EF produced cut CG at H. Okay, now what is given? It is given that this part AE, this part AE and this part BE, they are equal, and this part AF and this CF is equal because E and F are the midpoint. Okay, and we have constructed CG as parallel to this BA. What I have to prove? I have to prove that this EF is parallel to this BC and this EF is half of BC. Okay, so for that, what I will do, I will take two triangles, triangle AEF and triangle CHF or AFE. Let us write. First, let me make one more copy of this and paste here. Now I will say that in triangle, this is our proof. In triangle AFE and triangle CFH. Now you can understand that what I want to do, I want to prove them they are congruent. Okay, once I prove them they are congruent, I will get this EB is equals to this CH, and in parallelogram BCHE, this CH is parallel to BE by construction and CH is equal to BE, we will prove, and by that it will become a parallelogram, and hence this side EH will be parallel to BC, or we can say that this side EH will be EF will be parallel to BC, right? So this is the whole idea of proving these two triangles congruent. So in triangle AFE, okay, AFE. So in triangle AFE, if you see that angle EAF and angle HCF, angle HCF, EAF and HCF, they are equal because they are alternate angle. Already we have made the construction that these two sides are parallel. So these are alternate angle. Then we have side AF is equals to side CF. This is given, or I say that F is the midpoint. And third, angle AFE will be equal to angle CFH. They are vertically opposite angle. Right. So therefore we will say that triangle AFE will be congruent to triangle CFH. Criteria is angle side angle criteria. So these two triangles are congruent, therefore their corresponding sides will be equal. So therefore this side AE will be equal to CH and EF will be equal to HF. This I can consider equation 1, and this is by the reason of corresponding part of congruent triangle CPCT. So AE is equals to CH. AE equal to CH. Okay. Also, we know that this AE is equals to BE. This I will consider equation 2, and reason is E is midpoint of AB. Okay. So AE is equals to BE. Now, if you see this equation 1 and 2, we can say that this AE, which is equals to CH, this is also equal to BE. And let us take this as equation 3. Now in quadrilateral, I will say take BE. So we will take this quadrilateral. So again, now in quadrilateral BCHE, in this quadrilateral, your BE, side BE is equal to side CH. This is from 3, and your BE is parallel to CH. This is construction. Already we have drawn this parallel. Therefore, we will say that this quadrilateral BCHFHE is parallelogram. So this is parallelogram. So therefore, this EH is parallel to BC. Therefore, this EF parallel to BC. So the first part we have proved. Okay, EF and BC, they are parallel. Okay. Now EF or EH is equals to BC. They are opposite sides of parallelogram. Reason is opposite sides of parallelogram, or already we mentioned that this is a parallelogram. Therefore, this condition will satisfy. EH will be equal to BC. Now this let us consider this as equation number 4. Now EF is equals to FH and EF is equals to FH already we have proved in equation number 1. Okay, so you can say that from 1, this is from 1, and EF plus FH is equals to EH. Therefore, these two sides are equal and their sum is equals to EH. Therefore, this EF is equals to FH. It will be equal to half of EH. And this EH is equals to BC. So I will say that this is equals to half of BC from equation 4. So therefore you got EF is equals to half of BC. Okay. So EF is equals to half of BC. We proved. Done. Okay, so in a triangle, if you join the midpoints of two sides of the triangle, then the side which you will get is parallel to third side and it will be half of the third side. This is your midpoint theorem. Simple midpoint theorem. Okay, so remember this. And there is one more theorem that is called converse of midpoint theorem. Converse of midpoint theorem. I will not prove it. I will only discuss what is converse of midpoint theorem. So in a triangle, if I draw a side parallel to one side of a triangle from midpoint of any side, then that side will bisect the third side also. Okay, if we draw a parallel line to one side of triangle from the midpoint of other side, then it will bisect the third side. So the converse is that if E is the midpoint of AB and I will draw one side parallel to BC, then that side will cut AC at a point which is midpoint of AC. So if EF is parallel to BC, E is the midpoint, then F will also be midpoint of AC. This is converse of midpoint theorem. In this also, you are going to do a construction in the same way that is parallel to this BA, and then you will prove that these two triangles are congruent, and by that you will prove that this side AF and CF is equal, and hence you will say that F is the midpoint of AC, and hence your theorem. Simple? Okay. So let us see few questions based on this midpoint theorem. Also, whatever we learned in the previous topic, that also may be used in the problem. Okay. So first problem is ABCD is a quadrilateral. You can see this ABCD is a quadrilateral in which PQRS are the midpoints. PQRS are the midpoints of the side AB, BC, CD, and DA. AC is a diagonal. Yes, it is given. We have to show that SR is parallel to AC and SR is half of AC. And then we have to show that this PQ is equal to SR, and hence we have to show that this PQRS is a parallelogram. So given and to find, you can write from the question, you can draw the diagram, and then we will start with the proof. Okay, so I have to prove that this SR and this AC are parallel. So I will take a triangle DAC. I will say that in triangle DAC, S and R are midpoint of AD and DC. Therefore, by midpoint theorem, I can say that this SR is parallel to AC and SR is half of AC. So here it is 1 by 2. SR is parallel to AC and SR is half of AC. This, let us take equation 1, right? We have proved one part, so let us better put it in the box. Simple. By midpoint theorem, just now we have seen that if we join the midpoints of two sides of triangle, it will be parallel to third side and half of it. Now we have to prove that PQ is equal to SR. PQ is equal to SR. So for that you can take triangle ABC. So let us take triangle ABC. We have now in triangle ABC, P and Q are midpoints of P and Q are midpoints of AB and BC. AB and BC. Okay, P and Q are the midpoints of AB and BC. Therefore, again by midpoint theorem, we have PQ parallel to AC and PQ is half of AC. This is second. Okay. First is SR is parallel to AC, SR is half of AC. Second is PQ is parallel to AC and PQ is half of AC. This is second. Now from 1 and 2, we have SR parallel to AC and PQ parallel to AC. That means this SR and PQ are equal. What we have to prove? That PQ and SR are equal. So from 1 and 2, what I will say that PQ is equals to SR. Okay, this we have to prove. So we have shown. Let us put in the box PQ is equals to SR. Also, we have this PQ parallel to SR, right? Now, why I have written this PQ is parallel to SR, it is not asked. But the next question, if you see, we have to prove that this PQRS is a parallelogram. So PQRS is a parallelogram. For that, your one pair of opposite sides should be parallel and equal, or both the sides of opposite sides should be parallel. So instead of proving that, here we have already proved that PQ is equals to SR and they are parallel. So PQRS become a parallelogram. So as or directly as these two statements we are writing, so therefore I will say that therefore this PQRS is a parallelogram. So we have shown that one pair of opposite side is equal and parallel, so this PQRS is a parallelogram. Simple question. Okay, let us move to the next question. ABCD is a rhombus and PQRS are the midpoints of the sides of AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rectangle. Okay, so I have given rhombus. This is ABCD. ABCD. Then I have given PQRS the midpoints of side AB. So this is P, this is Q, this is R, this is S. Now when I join this PQRS, so if I join, we join like this. Okay, we have to prove that this quadrilateral PQRS is a rectangle. Now for rectangle, the property is that its diagonals should be equal, or we will prove that each angle is 90 degree. Okay, so in case of a parallelogram, if the diagonals are equal, then it will become a rectangle, right? Now So what I can do, I can construct, first of all, if I join this AC, if I join this AC, then this SR, as we seen in the first problem, SR will be equal to half of AC and it will be parallel. Okay, so that we can do. And what else? Okay, so here I will start with the proof. Okay, what you have to prove? You have to prove that this PQRS is a rectangle. You write given and to find. I will start with the solution. Okay, now as PABCD is a rhombus, here ABCD is rhombus. Therefore, I will take this AB is equals to BC is equals to CD is equals to DA is equals to XSA. Okay, so it will be easy for me, okay, to calculate the length of sides. Now we draw AC, we do one construction, we draw AC, join AC, draw AC. Now in triangle, if I take triangle DAC, in triangle DAC, S and R are the midpoints of AD and CD. So S and R are the midpoints of side, midpoints of side AD and, so S is the midpoint of AD and R is the midpoint of DC, AD and DC. Therefore, I will use midpoint theorem. By midpoint theorem, I will say that SR is half of AC, SR is equals to half of AC, and SR is parallel to AC. Okay, this I will take equation 1, and similarly I will say that similarly we can prove. So in the same way you can prove that this is parallel to AC and this PQ is half of AC. Okay, this is your second equation. So from 1 and 2, from 1 and 2, you have SR is equal to PQ, you have SR is equals to PQ, and SR is parallel to PQ. Therefore, this quadrilateral PQRS is a parallelogram. So this is just the same as we done in the previous problem. So what I have done, I have proved that it is a parallelogram. Now in parallelogram, if the diagonals are equal, then it will become a rectangle. So for that, I will draw diagonal. So we join this SQ and we join this PR. So let us first join this SQ. Now in SQCD, quadrilateral SQCD, if you see in, I have in quadrilateral SQCD, we know that this SD is equals to QC and they are half of X. This whole side AD is X, this whole side BC is X. So this SD and QC, they will be equal to half of this X, and SD is parallel to QC. So therefore this SQ CD. Here you can write it is given. Okay, both are given. This is also given. So this SQCD is a parallelogram. Therefore, this side SQ will be equal to DC will be equal to X. Similarly, we prove that the other diagonal, which is PR, this is also be equal to X. So therefore, you have SQ is equals to PR. So SQ is equals to PR. Now in parallelogram PQRS, diagonals are equal in length. So therefore I will say that therefore in parallelogram PQRS, diagonals are equal. Therefore this PQRS is a rectangle. There are different ways possible to prove this, that PQRS is a rectangle. Okay, comment me if you know any other method. Thank you. Now we will stop our lecture here and see few more problems in our next class. In this class, we have seen midpoint theorem and converse of midpoint theorem. Let us revise midpoint theorem again. Midpoint theorem says that if we join the midpoints of two sides of triangle, okay, then that the side which we get is parallel to third side and it will be half of the third side. And converse is that, okay, if we draw a parallel from the midpoint of one side of a triangle to the other side, then it will bisect the third side. It will bisect the third side. So if triangle ABC is there and from the midpoint of AB, I will draw a line EF which is parallel to side BC, then it will bisect AC, that is point F will be the midpoint of AC. Okay, so let us meet in the next class. Thank you.